Hello, welcome to the third video of the second class. In the previous video, I talked about the underlying structure of probability. We defined probability, experiment, and event, and population, sample size, sample space. They are simple, easy to understand what happened, and when you encounter a tricky problem, those basic concepts may be very important. And now I will start thinking about data, actual data. So here, let's think about again the simple dice rolling example. Suppose that you roll a dice for 200 times. Then and you record the outcomes. That's the data. So and the data would look like this. Experiment number 1, you get 1. In the second experiment, you get 5, and third 4, and then fourth 4, da 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 da, and you record 200 numbers. This is the raw data right after the experiment. This is okay. This is the data story, raw data, but it is not convenient to handle. You cannot present the data just as it is because this table does not summarize the data at all. Originally you had to imagine 200 data going down here, so you cannot present this data without any manipulation. So I will summarize the data by a frequency distribution table. This is a frequency distribution table. We summarize that there are 6 different outcomes in our data, and each outcome has this number of occurrences. So among 200 repetitions, the outcome 1 happened 33 times, and outcome 2 happened 31 times. And there are 6 different outcomes, so there must be 6 frequencies. And sum of 6 frequencies should sum to the total number 200, total sample size, right? So frequency is the number of occurrences for each outcome, and sample size is sum of the frequencies or the total number of repetitions. And and many students are confused between this frequency distribution table and raw data. The key difference here is outcome is written in here. So it is just marking outcome for each experiment. You have to think about what is recorded for what. It's for each experiment, you record the outcome. But in the frequency distribution table, for each outcome, you are recording their counts. So you have to think about whether this table is a summarized one or not. Then if you get the raw data, then you have to summarize the data first. And if you get the frequency table, you can just start from here. And and then from the frequency, you can calculate the probability. It should be super easy. It should be like everyone knows how to calculate probability in this simple case. So basically, probability is the ratio of the frequency to the sample size. Out of 200 times, outcome 1 happened 33 times. So their ratio, 33 over 200, is the probability. It is 16.5%. And the second outcome happened 31 times out of 200. So it is 15.5%. That's simple math. And of course, the sum of the probabilities must be 100%. In any case, should be 100% all the times. So its calculation is super easy. I'm not going to do this. And then Let's try this. In this data, what is the probability of getting an even number? Getting an even number is not directly given in the table. So it is easy. You may use a calculator or a computer. So try this. Pause the video and just try this. And I assume that you have done this after pausing the video. Now I'll just tell you the answer. It's this. So when you calculate the probability of an even number, you have to check which outcome falls into that event. When you say even numbers, there are three different outcomes included in that event, and then sum those probabilities. That's how you calculate the probability in general. And in this case, by the way, there are three different ways to write a probability. You may use percentage, you may use decimal, you may use fractions, but they are equivalent, like mathematically equivalent. There is no difference. I may switch between them within an equation or like between lines. But one caution you have to understand is using the percentage in algebra can be a problem. For example, 20% times 30% is not 20 times 30. You have to multiply them after transforming them into decimals or fractions, and then calculate the multiplication, and then convert it again back to percentage. So it can be confusing, tricky. So to prevent potential mistake, I recommend you to use fraction or decimal in algebra. Otherwise, you may make a mistake just because of using percentage. But I may use percentage in many slides because it's convenient and easy to understand. But just in algebra, I'm telling you. So, by the way, coming back to the probability. So now I tell you the general rule. Probability of an event is the sum of probabilities of outcomes included in the event. Here, in our previous example, we considered probability of an even number. Even number is not a single outcome. There are 6 outcomes, but even number is not one of them. Still, it is easy to define the probability. So we can define a new concept here. Event is where the probability is defined, where the probability is assigned. So probability can be assigned to outcomes, but not only to outcomes. Outcome, it means just one single outcome, but event may have multiple outcomes. And then its probability of an event can be calculated as the sum of probabilities for the outcomes included in the event. So you have to tell the difference between event and outcome. It's a statistical distinction. And examples of an event. Just one single outcome itself can be an event. Just one outcome is an event because you can attach probability there. And you may include multiple outcomes. Any set of multiple outcomes is an event. Even numbers can be an event. Odd number, of course, is an event. And you may choose any number, like numbers greater than 3 is also an event. So any combination of outcomes can be an event. And also, a little bit strange event may not include any outcome. So what is the probability of, when you roll a dice, what is the probability of getting a 7? Its probability is 0. But it's okay. Probability is defined. Just it is not possible, so probability is 0. So an event may include like impossible outcomes, or there may be no possible outcomes. On the other hand, an event may include all possible outcomes. When you roll a dice, what is the probability that you get a positive number? 100%. You always get a positive number. So that's a reasonable, like legitimate probability. So that is a well-defined event. That's how we define an event uh, which is different from an outcome. So um, so far we have considered very basic examples, basic concepts, and in the next slide I am going to show you a more real data. Using the real data, we will study a little bit more complicated concepts. Thank you for listening and see you in the next video.